Hey everybody, welcome back to the Rule Your Pool podcast. I'm your host Eric Knight. This is episode 125, and this one is going to be different. Normally on the Rule Your Pool podcast, we talk about tangible things like water chemistry advice or physics and how to actually dilute chemicals and things like that that are directly affecting how you treat water. Our mission at Orenda and with this podcast and our website is to purify water by empowering people who treat it, whether you're the pool owner or a pool professional. And so we try to make this podcast as informative as possible. This one's a little bit different because we do have a growing audience in commercial pools. Thank you for listening, by the way. If you have ever used an indoor pool and smelled it, you know, that pool smell, that's not actually chlorine. That is chloramine. And we use the term chloramine or chloramines to generically describe all of the off-gassing byproducts of chlorine oxidizing things, primarily nitrogen compounds. When people pee in the pool, for instance, urea is organic nitrogen. So you have a lot more complexity when it comes to chlorine getting rid of this stuff, and it off-gasses a whole bunch of things, like hundreds of variations of byproducts. That makes up the pool smell. And that smell is a symptom of pollution, and it's not healthy. That rasp in my voice is from permanent lung scarring from swimming almost a decade of my life indoors. It's the reason why I'm in the industry. I know we talk about a lot of different things in pool chemistry, but the reason I'm here originally is because I got very sick swimming indoors, and it's deeply personal to me to fix this problem. This episode, we're going to talk about indoor air quality. In particular, this is a special episode because my guest, who I recorded with earlier today outside on my deck, has been on the forefront of fixing indoor air quality problems since the beginning of the emerging technology that we're going to talk about. In particular, we're speaking about ventilation in indoor pools to handle the pollution that I just described. And the reason this is a special episode is because you would not know the name of the gentleman that we're going to be honoring in this episode. There's a high probability you've never heard of him. His name is Ingram. Derek was my coworker for many years, where it was just he and I for several years trying to develop this new technology called the evacuator to get chloramines out. We ate lunch every day. We spent, the entire working day together for 3 years. Derek was never a swimmer. It started out as a job, and he didn't know swimmers personally, didn't know coaches, but it became more than a job. It became a vocation. This man was unbelievably dedicated and devoted to the mission of fixing indoor air quality problems for pools. And without the level of detail that Derek put into everything he did, the technology that fixes the indoor air quality problem would not be nearly as far along today as it is. It is now becoming widely accepted as the standard for new commercial pools to put this ventilation system in every time, as it should be, because the pollution is going to happen every time. There should always be a way to suck that pollution out of the room effectively while it's married up to the pool dehumidification system, etc. Now, I know we don't talk about dehumidification much, and we may talk a little bit about that in this podcast, but that's a different topic for a different place. But the point is, all of us have probably been in an indoor pool. And if you are lucky enough to go into a facility that has one of these systems in there and you're breathing fresh air, there are a lot of people to thank, but probably number one on that list is Ingram. Derek took a concept that had a lot of people involved. We're going to drop some names here. Don Baker, Jeff Gackle, Chris Adams, Tom Lee, Randy Baxter, Dennis Ingram, my guest today, and a lot of other people that I can't name everybody, but a lot of people took this concept and made it into something that is becoming standard. And I couldn't be happier about it. It makes a huge difference. And it's my mission, personally, to fix as many natatoriums as possible so that people can breathe freely. That mission would not exist to the level that it does today without Derek and his work. Derek was an architecture student out of Clemson, and he was a hell of an engineer for an architect, I'll tell you that. He took designs and calculations and really brought this system up to being at a professional standard so that engineers would look at it and say, okay, I get it, this is up to my standards, and then they would be able to put it into their drawings. Whereas before, without the level of CAD drawings and details and specs and cut sheets and all the stuff that Derek created, most people wouldn't even give it the time of day. But because of Derek, it has become the standard of care. And for that, we should all be grateful, whether you use indoor pools or not. If you know people who do, as this technology takes over, as it should become a required thing for indoor pools. It's just common sense. You have to address the pollution. It's going to happen. What do you do about it? That technology is only possible because of what Derek did. The reason this episode is so special, not only to me, but to anybody else who knew Derek, is because we just lost Derek. Derek just tragically passed away about 2 weeks ago after almost 2 years battling ALS. And if you've never seen that disease, it is horrifying. It's really hard to watch somebody, especially Derek. I mean, I'll just give him a little bit of a tribute here. He was a great man, young man, 39 years old. I watched that guy start with what he thought was Crohn's and turned out to be ulcerative colitis. And he had so much pain. And this was in 2014. Long story short, after multiple hospital visits and multiple infections and multiple issues here, there, everywhere, he just kept going back into the hospital. They found out his liver was dying. And it was a genetic defect. It had nothing to do with behaviors. He wasn't an alcoholic. He never did drugs. He didn't smoke. And yet his liver was failing on him. Fast forward over the next 4 years and just tremendous pain and agony throughout those 4 years. He's going to die if he doesn't get a liver transplant. And a miracle happened in 2018. He got one. Eventually, he was the sickest person in the Carolinas, and with maybe a few more days left to live, he got a liver, and it was a miracle, and he recovered fully. It was amazing. He's on immunosuppressants, and then boom, COVID happened. Here's a guy who has to take immunosuppressants so that his liver works, and a pandemic happens. And then he got COVID. And amazingly, he survived COVID as well. And all the while, after getting this liver, he had 2 more children. And 3 days after his second daughter was born, his third child, he got diagnosed with ALS. This could not have happened to a less deserving father, to a less deserving person. And what's so cruel about this disease, it's really hard to talk about, but every time I would visit him, he was still in there, and his body was failing around him. I last saw him about 3 weeks before he passed, and at that point, he can't talk anymore, so he's using his eyes to speak on a computer. I had this running joke with him. He was a devout Clemson fan. I mean, every day he wore Clemson stuff and had Clemson stuff all over the walls. And I always just act surprised, like, wait, what? Since when are you a Clemson fan? Or their big rival is the USC South Carolina Gamecocks. And I'd say, man, this was really good work for a Gamecock. And, he's a Gamecocks fan. And anyways, this joke never died. I regret nothing. If you're listening, Derek, I regret nothing. And I showed up, and he's wearing a Clemson sweatshirt, and he's got his nurse there helping him. And I said, gosh, why does Amber keep putting you in Clemson gear? It doesn't make sense. That's got to drive you nuts, Derek. And he writes out on his computer screen, "It's still not funny, Eric." He was still in there. Derek leaves behind an unbelievably loyal and faithful wife, Amber, who has stuck with him through everything. And I mean, it's a lot. She's been there the whole time, through a failing liver, through all the infections, through the myriad hospital visits and pain and agony, and then the entire battle with ALS, where she was not only having to raise 3 young kids, but also being his primary caretaker. I don't know how she does it, but God put her in his life for a reason. And Amber, if you're listening, you are a saint. Derek also leaves behind 3 beautiful children, Bo, Kate, and Elle. And hopefully they remember enough of their father to cherish just how good of a man he was. And we are honored today to have his dad. He has a depth of knowledge, I would put him up against anybody in the country that I know of being more knowledgeable in a commercial pump room. Doesn't do anything with residential, but in a commercial pump room, this guy can build them, and he's built hundreds. He can fix them. He's fixed thousands. He knows commercial pools better than just about anyone I know. Dennis Ingram is our guest today. It's a particularly hard episode. It's so soon after the loss of Derek, but for what Derek did for the commercial pool industry and for not having his name ever put out there, people didn't know he was the guy behind the scenes doing it. I think anyone who uses indoor pools should be saying thank you. And with that, this is episode 125 of the Rule Your Pool podcast.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Welcome back to the Rule Your Pool podcast. If you can hear it, we are outside, and I have a very special guest with me sitting here next to my fixer-upper pool, Dennis Ingram. Thank you for being with me.
All right.
So for those of you who don't know Dennis, Dennis is a commercial pool operator, but kind of a service technician, repair guy. You've built out a ton of pump rooms on commercial pools. You probably know more about a commercial pump room than anyone I know. And I got to know you years ago with my years at Paddock Evacuator, and that's what we're going to talk about today. Commercial pools, indoor air quality, and sort of the origins of how you've been at the forefront of fixing that problem. So welcome to the show. Thank you.
All right. Thank you. I've done a few pump rooms here and there, but a few years.
A few hundred?
Yeah. My background is actually plumbing, HVAC work, and that's one of the reasons that Don felt I would be good with the whole indoor air quality issue, and he brought me on board for that, and we took off. But it was an interesting journey for sure.
So let's go back to the days before the evacuator was created, pre-2009. You've been in pools for a long time. Rust, corrosion, people coughing. I know I personally got sick. I had my first asthma attack in 2009. My pool was a bromine pool in college, and then it converted to Cal Hypo in 2008, and that's when I started getting sick. I actually didn't have issues when it was bromine. Some other people did, so it's a tolerance thing, but I was intimately familiar with how much this problem hurt. Right. And by the time I came to Charlotte in 2011, I had been using an inhaler for over a year, all the time, every single day. So the way I was introduced to it was Don Baker and Jeff Gackle showed up to our practice when I was on Team Elite, and they had just put in that bench at Johnson C. Smith, and they said, hey guys, how's the air in here? And I thought, now that you mention it, I haven't had to use my inhaler in a few weeks. And they explained, hey, we're pulling this heavy gas that's making you sick, that you're breathing in all the time, that chlorine smell, and we're just sucking it out of the room. And I was sold immediately because it was clearly working. So take me back. What was it like before, and then how did this originate? Because you were there. You were on the front lines.
I was actually out building these pools and training people and learning about chemicals and such as this. And, being a kid swimming, you walk into an indoor pool and your eyes are burning and, but you don't know what that is. I mean, you just assume it's chlorine like everybody did.
Right.
And a lot of people probably still do, we're bringing it out, and it's more and more people becoming aware, but you didn't really realize it's such a big problem. You being a swimmer, of course, knew something was up, but so I think it all originated from a meeting they had about rebuilding a pool facility in Greenville, South Carolina, a West Side Aquatic Center. They were tearing the building down because it had rusted through, and it was only, I think, like 15 to 17 years old, and it had already got to the point where it was not safe to be in the building. They had an engineer that was on the board, and they had several pool builders there to come in and give bids and quotes to rebuild this whole facility. And so his question to them was, what are you going to do to prevent this from happening again?
And that was Randy Baxter, right?
Yes, sir. I believe that's correct. So everybody just kind of looked at each other, and after the meeting, I think Don Baker, the owner of Paddock, and Tom Lee, one of the sales guys, were on the way back, and I think Tom actually come up with an idea. Why don't we put like a exhaust fan in there of some sort, and it kind of all started from that.
Yeah.
And then from there, we started putting ideas together. We had the other HVAC engineers come in and work with us as well.
I remember Chris Adams was one of those guys
Yep,
who came
absolutely.
down.
Yeah, Chris was a big help with us. But we started putting it together, designing it, and it just evolved into what it is today. I've been to a lot of facilities. We actually had this thing, we called it the road show, and we would go out and temporarily install it and set it up, and if it was in the right place, it was amazing. I mean, it would just blow people away.
I remember we went to that YMCA where they had that wall between them that almost had the fireplace, but it was two chases. Remember, you had like the water park on one side and then the lap pool on the other.
Yeah.
We put that temporary system in there. And it was like 5 minutes later. It was amazing. A little bit of context, since most of our listeners are either homeowners or residential pros. When I got to Orenda, the first time I saw a residential pool system, my reaction was, where's the rest of it? Because you're laughing because I was so used to commercial pump rooms with the years at Paddock that I'm going in there, there's automation controllers and these big filters I could fit inside, and there's all sorts of this equipment, these massive pumps, and I was just stunned at how simple a residential system was. And I think you could speak to that too, that a residential system is really a very simplified version of a commercial pool system. Would you agree?
Yes, absolutely. And 180 degrees from that, we've had guys come from residential pools over to work with us, and I take him out to his first pool, and he walks in there, and it's like a deer in the headlights. He's like, what is all this?
Yeah.
So, I mean, there's a lot that goes into commercial pools. You get into UVs and heaters and, all kind of stuff, which you have that on residential as well, but it's just a lot larger pipes and larger pumps, larger filters.
And larger risk, too, because if you close a valve, the amount of pressure in a commercial pool, you're using Schedule 80 pipe, not Schedule 40, right?
For the most part, yeah.
Well, outdoor commercial pools basically have the same chemistry parameters that we're used to with residential, just an exponentially larger bather load. Higher turnover rates, ideally, a lot more filter square footage, but disproportionately higher bather load, especially with people wearing sunscreen and swim teams and all of that. When you put that indoors, the byproducts of chlorination in these environments creates chloramines. And we've talked about this in previous episodes, and it's all over our website. But chloramines is a big buzzword that if you're unfamiliar with it, this is the stuff that off-gasses, and this is the main culprit behind the pool smell. But the truth is, in our industry, chloramines is a very generic term to refer to all byproducts. And so anytime you have chlorine byproducts of chlorine oxidizing anything that contains nitrogen, basically, whether it's organic or inorganic, we just call them all chloramines. We probably shouldn't. There's cyanogen chloride, there's chloroform, there's trihalomethanes beyond chloroform, lots of different things. But we're just going to use the word chloramines generally. And when we're talking about chloramines, in the water, they're known as combined chlorine. In the air, this is the pollution that's called the pool smell. We just call them chloramines. And chloramines are highly corrosive. When they condense on metals, they're loaded with chlorides, which are corrosive to metals to begin with, and they have a very low pH. Dennis, you remember when we took the condensation out of the evacuator on that YMCA and it had like a 19 part per million chlorine level?
Yeah.
It was crazy. And the pH was like 3. And so we see the runoff from these big pool dehumidifiers etching concrete outside, and the sidewalk is showing the aggregate where the water runs. We got photos of it.
Yeah.
The rest of the sidewalk's fine. And so this is very corrosive air that's corroding things. If you are a commercial operator, or if you've ever spent time in an indoor pool, if you see rust that looks like it was orange spray paint almost, like spots on metal, stainless steel in particular, handles of doors, starting blocks, backstroke flag rails, any rail goods like that, that's chloramines.
Yep.
So that's the big problem we're talking about here. And Dennis has been on the front lines of not only developing the technology, but installing it, figuring it out and helping perfect it. And I want you to speak on that a little bit more of the story. So we started at the West Side Aquatic Center in about, I think that was 2008 or 9. Where did it go from there?
Well, back in house, Derek came in as well. He was doing a lot of the engineering on it, if you will, calculations and such as that. A lot of times I'd go out and measure these facilities and look at them and try to determine the best location to put an evacuator. And one thing that we learned is that we wanted to use the HVAC airflow. That was a very important part, because none of these are cookie cutter units. If you just went in and put an exhaust fan in, it would just suck your conditioned air out, which is money, because you're paying to heat and cool the air in these facilities, and you just don't want to suck that out. We figured out how to use that air flow to our advantage. And you were talking about the rust on the equipment. One thing we figured out is the chloramines are so much heavier than air. So all your rust starts usually really low down at the floor level. Yeah. You'll see it. And
we call that the breathing zone, right where the swimmers are at the water surface.
Exactly.
That's the highest concentration. Yeah.
Exactly. We figured that out. We determined that's where we needed to pull the air from, is where it's just saturated with chloramines, and get that out and let the good air quality, which is usually high, come back down so you're breathing in good air. We went out and did a lot of test runs, putting in the Roadshow, which was a temporary unit, and just seeing what would happen. We did videos. We used that liquid nitrogen.
If you ever YouTube chloramines or evacuator, like paddock evacuator, you're going to hear Dennis's voice saying, "This is a liquid nitrogen exam." yeah. Those were the early days.
Yep. And I mean, it was actually an enjoyable time doing this. We installed a bunch of these things. It was a trial and error on a lot of it, but we figured it out and kind of got it down pat. But it's got a lot to do with the airflow, and the HVAC contractors could, rule the world with this. I mean, they could be the ones that actually set the precedence as far as whether it's a win or lose situation on these indoor pools. But anyway, it's just all a matter of figuring out your airflow and then getting those chloramines out.
So let's give a visual, because you say we're putting in this Roadshow, this temporary system. We're not going to get into the technical specifics of it, but essentially what this is a new exhaust system. So it's a capture point for heavy pollution in the air, because good air, heat and humidity come out of this pool. Heat and humidity rise and expand. And so from a dehumidification standpoint, you have to have a properly sized pool dehumidifier, not an air conditioner. Huge difference between a pool dehumidifier and an air conditioner. And we don't need to get into that now, but we can if you want to, Dennis. But if you condition the air, you have to do something with the pollution. And the reason for that is the old way of doing things, until recently, ASHRAE is the standard that the HVAC industry uses, and they have updated their standards quite a bit. The old way was you would put the exhaust as part of the return path. If you do that, that exhaust fan doesn't have the ability to just pick and choose the pollution and pull that out. It's just pulling out a percentage of the airflow. And so it can't distinguish between good air and bad air. And as a result, if you were returning air back to the dehumidifier that was low in the room, it was loaded with pollution. It was basically chain smoking cigarettes. That's basically what it was doing, is chain smoking chloramines and then blowing them right back into the room. Conversely, if you had a high return that's high up in the room, it stagnates and there is no relief, because the chloramines just build and build and build and build and build, and eventually they get stirred up enough that you start to get some out. But all the exhaust was pretty much in the return path. And I should note, before passing this mic back to you, the word return is the exact opposite in HVAC that it is in pools. You're smiling because you know. When you return in a pool, you are returning to the vessel. You're returning to the pool. In air systems, it's the opposite. You're actually returning to the system to condition the air, and then you supply the room. So it's different. What the paddock evacuator did was such a paradigm shift, because it was the first system that proved you could separate the air streams. You could separate and capture the pollution while recirculating the good air. And you could take it so you would just disable the existing exhaust fan, or on a new system, ideally, you just design it this way. A separate fan, separate path. You never recirculate chloramines. You get them outside. And that way, it's fresh air inside. You're never recirculating chloramines. Now, they'll always be produced because bathers are always using the pool, and as a result of that, you will have these byproducts that off gas. The key is, do they build up to a point where they start to annoy swimmers like me or get us sick? And the answer is generally no. If it is properly designed, no. You're going to have a constant sweep of air. You're going to be constantly pulling this pollution out and recirculating the good air. And that's the whole point of the evacuator. That technology would not exist if not for the people that we've already mentioned in this. And specifically on the front lines of figuring this out was you, Dennis, and your son, Derek. And so I want to talk about like that legacy that Derek has left behind, if you're comfortable doing that, and let's honor the work that he's done.
Well, he did a lot of the design, figuring the loads and stuff. Like I said, it's not a cookie cutter design, and we had to figure out how much air we could pull out without pulling out the conditioned air. So that was one thing that we did. We had to know how much, return they were putting into the building, how much fresh air, because you were going to pull exhaust so much air. So we basically got to the point where we would just take out all the exhaust air and let the building circulate air. So it was not really exhausting anything. We were doing all the exhausting of the air. And it was always the low, the chloramines, if you will. But Derek was in on a big part of it, and we got to a certain point, and I moved on and went back to the service industry, and he stayed there, so he had it all on his own. But he was very instrumental in the design and such as that.
That's about the time that I got involved. That was about 2012. So you went back to servicing and building pump rooms and commercial pools, right? And right around that time I came in, that would have been about 2012, after Olympic trials I came in. Yeah, 2012. And, for an architecture student, Derek was a hell of an engineer.
Yeah, absolutely.
He would probably resent me saying that, but basically the technology was a concept that came from an idea. Maybe this is possible. And a lot of credit goes to the other people involved with this. And some manufacturer said, okay, we see what you're doing. We like this. And dehumidification companies started saying, we'll actually modify our sequences and our controls so that we can control this new fan that you're putting in to keep the air balanced. That was a huge shift, because with their credibility and their rep groups and their connections to engineers, we were able to get a lot more credibility for this idea. It wasn't about us as a manufacturer. It was the fact that now engineers understood the nature of the problem and there was an answer to it. Some manufacturers, like Desert Air, went as far as to create an entirely new product just to exhaust chloramines. It was double coated, and it reclaimed a lot of that latent energy, meaning heat, and actually could put that heat back into the pool to help heat the pool and offset energy costs. So there were a lot of different things that took this good technology and made it into a great one. And that was, it started in 2009. It's 2023 now. It is now being widely accepted. And that, kudos to you and to Don, but especially to Derek, because none of this would be possible without Derek. And I really want to take this time and honor the work that he did, because if you, as a listener, ever use an indoor pool, you may not have this technology yet, but there's a possibility that you will in the future, or the next one that is built will. A very high likelihood that the next indoor pool at least should have this, and that would not be possible without you and Derek. So thank you for your contributions, and let's talk about him a little bit so that people who've never heard his name get to know who he is and who he was.
Very OCD. Everything had to be perfect. Yeah. What is there to say? He was hard-working, dedicated to it, which he stayed on it up until, he had to leave. But I think he was still working on it. They got it to where they could put it into the gutter system. So when they're building a brand new pool, the evacuator could be put into that. You were talking about the companies that are accepting it now, but back in the beginning, nobody likes change. So in the beginning, everybody was like, "That's not going to work. That's not going to,"
Snake oil.
Yeah, exactly. I heard that once. I heard it a million times, but that was one of the reasons we did the roadshow, to prove it. And as it started catching on, they started going, this is a real deal. We just kept doing it. Derek kept on with it. Like I said, I left, and so he basically had it all on him to keep it going, and any designs that had to be changed and such as that.
Well, you mentioned OCD. I have a couple stories about Derek. So we shared an office, Derek and I, and when I say OCD, or when Dennis does, he means it. Like, we're talking shirts in his house folded perfectly in order of color. Yeah, everything. The closets were the most meticulous thing. And his desk, he had these pens, like a green one, a red one, a black one, a blue one, and they were perfectly aligned. And so I got to this thing where after he would leave, I would just turn one around, just see if he would notice, or I would shift one out of alignment. And oh gosh, it got him so annoyed. You're touching my stuff. one time he had this to-do list that he would write in perfect handwriting. And I mean, he must have written at the speed of a third grader, but so meticulously perfect handwriting. And I took another yellow pad next to it and just added in 3 or 4 items into his to-do list. So I would copy exactly his handwriting the best I could, and it took me like 20 minutes at least. I had to go so slow. And I added things in like do Eric's laundry, clean Dawn's car, that kind of thing into his to-do list. It was really funny to mess with him. But that attention to detail that Derek had really elevated this to even being viable with engineers. Because if you just throw out a lousy shop drawing, they're not going to take you seriously. The fact that Derek did architectural drawings, he was an architecture major at Clemson. He was super good at it. I mean, it was a real gift. This guy could do CAD drawings to the nth degree of perfection. And that took the evacuator to that professional level. Otherwise, it may never have taken off. You got to be proud of that, and it's worth being proud of.
Absolutely. It was great. I mean, we had a good time working together. We got to travel together some, but he was so meticulous with everything, it would drive me crazy at times just because there were things I do, and if I do something, I'm gonna do it right. That was pretty much the way my dad would do it. If I didn't do it right, I had to do it again, and I hate to do anything twice. So I got to where I did everything the first time, but some of his stuff would be so perfection that it was like over the top, and I'm like, all right. And so we had our differences on that, but like you said, his meticulous attitude and to detail and such really, I guess, put it up where it needed to be.
Well, beyond that, you can't just exhaust air low in a room. We found out. We tried it several times. Like you said, it was a lot of trial and error. You can't just do that and be successful every single time. And it got down, this is the precision we're talking about. Derek figured out to get a laminar flow, which means a flow of air across a long length. So like the length of a pool, not just from one corner of the room. Each intake, which we called them slots because they were narrow and tall, each intake hole was precise to the centimeter. I mean, he had it down. He knew the exact width and height of these things, had calculated it to the nth degree. So you could plug in an air volume and then plug in the length of the bench, and it would design it for you. Yeah. It was pretty unbelievable what Derek came up with. And I got to give him credit because this is a man who never competitively swam, never really knew the end users. Like I was an end user. I was deeply personally tied to this problem. Derek wasn't. And yet it went from a job to a vocation, every bit as committed to that mission to help these people he had never met, who may never know his name, who may never say thank you because they just take it for granted. You don't think about bad air when the air is good. And if you do have bad air, you just think, well, that's normal. That's just what a pool is. That's the pool smell. And so we get used to it and we rationalize it that, oh, yes, this must be okay. It's not okay. It's not supposed to be there, but it is how things have been for a very long time. And he deserves a lot of credit for that because had he not taken it so seriously and so personally to help these strangers, really, we wouldn't be where we are today. And you raised a good one there, Dennis.
Yeah, thank you. He's going to be missed for sure. He's he was the easy one, I guess. But
that's saying a lot.
yeah. But he was a good kid. I never had any issues really with him coming up. He was always a go-getter, if you will, and I mean, what do you say? I mean, I'm bragging, so
you get to.
Yeah.
Normally, you don't get to. You get to right now.
Yeah, but one of the best, I guess.
I'll say this. Yeah, he'll be missed, but his work will live on. I'm personally committed to continuing that mission. I know you are as well in our own ways. We're in different aspects of the industry, but the work was never in vain. That's the point. We're going to take this to the next level. We're going to continue on. It's a hard time for all of us, but it means the world to me that you came here and we talk about this issue and about Derek, really. We honor him. Is there anything you want to add? Because these people that are listening, some of them may have interacted with him, but not many. But all of them, if they ever use an indoor pool, can be grateful. The work that Derek did impacts pretty much every indoor pool moving forward. So I'm personally very grateful for it forever. But if there's anything you want to add, then otherwise we'll wrap up here.
Okay. I'm good.
You good? Well, Dennis, thank you so much for being on this podcast and telling the story of air quality and Derek. So if you use an indoor pool, we are grateful that you're supporting the industry because they're not building too many of them anymore. A large part of that is the air quality challenge. They're a lot more expensive to build, a lot more expensive to operate, but they're necessary for sports like swimming, water polo, synchronized swimming, diving, things like that. And I know most of this, we talk about water chemistry, we talk about backyard pools, but commercial pools are a big part of our industry as well. So we're grateful for you. Thank you for listening. This has been episode 125. We'll see you next week.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.